Welcome. This is 4.4, solving using the quadratic formula. We've learned 3 other ways to solve using factoring, using square roots, or completing the square. Okay, so all 3 of those ways are great ways, but some of them are a little more complicated than others. Now we're going to talk about the quadratic formula. The nice thing about the quadratic formula is that it will always work, okay, for any type of quadratic. It doesn't matter if you can factor it. It doesn't matter if you can square root both sides or completing the square. If you can't complete the square, then this will always work, okay? So you're going to memorize this formula, and I'll teach you a way to help remember that, because this is kind of a big monster. It's x is equal to negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. And again, when we're talking about a, b, and c, that's from standard form. So again, standard form is ax squared plus bx plus c equals 0. So if I gave you an equation, we need to make sure everything is on one side, and then we can easily, and if it's in standard form, meaning we have the highest exponents down to the constant, okay, then we can easily find a, b, and c, and then all we need to do is substitute and simplify. Okay, so here's how you can remember this formula, is using song. Okay, so this is how it goes. It goes with the tune of Pop Goes the Weasel. It goes, me, 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 me. Here, okay. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so what I would suggest is maybe pause and go back and go listen to that, because that was beautiful, first off. Second, the more you sing this, the better it'll get memorized in your brain, whether or not you want that stuck in your brain. You may want it for the test, okay? So you will need to be able to write that down on the test so that you can do problems using the quadratic formula. Okay, so we'll do it one more time. Sing it with me with gusto. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Great, good job. Okay, just remember a, b, and c, those are just those coefficients in the constant that we talked about right here. All right, so first thing, we may be talking about discriminant. Okay, discriminant is the stuff that's inside that square root. So the discriminant here is b squared minus 4ac. And we can kind of look at the discriminant and decide what type of solutions we'll have. All right, so if I ever talk about discriminant, it's just what is inside the root, okay, for the quadratic formula. Okay, so when can I use the quadratic formula to solve quadratic equations? Okay, always. This works all the time. Okay, on the test you'll be able to, for some of the problems I'm going to ask you to do it specific ways, but for the most part you can choose what method you'd like to use. Like the multiple choice section, you can choose it however you want. So if you're really good with the quadratic formula and you are good at getting the right answer every single time, then you may want to do that, okay? Or sometimes you may want to do the other methods, depending on how easy it is for you. All right, so let's just do some problems. Let's see, what do we have here? Some tips and things like that, okay? I will be going over all of these problems. I would suggest watching it until you get it. Make sure these like boxes, and we talk about the tips and things like that before you just be done. But Let's do an example together. So first step, what I will ask you always to do is to label A, B, and C. So this is already in standard form. So here A, what does A have to be? Well, it's got to be 1. B here also has got to be 1. And C is a negative 110. Okay? I mean, you could possibly, I don't know, this might work if you factor. This is not, you can't use like square roots to solve our second lesson. Third lesson, we wouldn't want to do completing the square because B is not even. So I think quadratic is a really good choice for this one. So now we'll plug everything in. So again, it's x equals negative b, so negative 1, plus or minus the square root of b squared, well that's 1 squared, minus 4ac. And again, if you plug stuff in, I think it's a really good idea to just, for substitution, put a parenthesis around it. I guess I didn't do it here or here, but I think it's a really good idea to put parentheses around whatever you substitute in. All over 2a. All over 2 times 1. Okay? So that's our first step, is to just substitute it in. As it is right now, that is correct. Those are the 2 solutions. It's really hairy, really scary, but we should simplify it if we can, and I know we can. Okay, so the first thing we'd want to simplify is the discriminant. So what is inside? You may just want to use a calculator. So that's probably what I will do, because 110, that's kind of scary. All right, so, and this is kind of like Halloween kind of stuff, so that's why we're doing like the scary stuff now. So we'll do in parenthesis 1, close parenthesis squared, minus 4, and then a parenthesis 1, and then another parenthesis with a negative 100 and 110. Okay. Make sure that you use negatives instead of subtractions when it's supposed to be a negative. So like this would be a negative, this would be subtraction, if that makes any difference to you. Okay, because you could come up with some mistakes that way. Okay, so we plugged that in our calculator, and for me, what I got was, so we still have our negative 1 plus or minus the square root of 441. All over 2 times 1 is 2. So first thing, we want to simplify the discriminant. The denominator, we want to simplify the denominator. Okay, d and d. All right. Now we want to simplify our root. So I'm not sure. Let's see, what is the square root if it's a perfect square? I don't think so, but we could sure try. Square root of 441. Oh, it does. It gives you 21. So here we want to simplify the root. So that gives us x is equal to negative 1 plus or minus 21 over 2. Okay. And then we want to simplify, I guess, the numerator. Okay, so here we're going to have 2 solutions. We have negative 1 plus 21 over 2, and that would give us 20 over 2, or 10. So one of our solutions is 10, and then the other would be negative 1 minus 21 over 2. Well, that gives us a negative 22 over 2, which is a negative 11. So these would be our 2 solutions. So looking at that, since these are like whole numbers and they're kind of nice numbers, we could have done factoring for that problem. Those would be the 2 things that would multiply and add. Those 2 would multiply to give us a negative 110 and add to give us a 1x. So we could have done it that way, but for this lesson I'm asking you to do it with the quadratic formula. Okay, but like on the test, you could choose which one you wanted to. All right, so here's another one. Pause and give this a try if you'd like. Okay, again, these are kind of the orders of simplification. First is the discriminant. If I spelled that wrong, I'm not sure. Then maybe the denominator. Denominator. Okay. And then we'd want to simplify the root, or the radical, however you want to say it. All right? And then we would want to simplify the fraction. Okay, so these are the 4 steps on how to simplify. So first step is to just plug everything in, and then all we need to do is simplify. All right, so hopefully give this a try if you'd like, or you can follow along. Okay, here A here is 1, B here is 11, and C is 18. Okay, you could, like if it was on a test, you could try factoring. Okay, anyways, so now we'll plug everything in. X equals negative B plus or minus the square root of B squared minus 4AC all over 2A. Okay, again, so that is your 2 solutions. We just want to simplify it. So we'll simplify the discriminant, what's inside. So I'll just do that on my calculator. 11 squared minus 4 times 1 times 18. And that gives me 49. So negative 11 plus or minus square root of 49 over 2. So this would be the second step, maybe, would be to simplify the denominator. So that just gives you 2. It's already looking a lot better. Okay, now we'll simplify our root. That gives us 7. So negative 11 plus or minus 7 over 2. And then we have our 2 solutions. Okay. If we can simplify our fraction, we should. But we can't. 2 doesn't go into 11 or 7. So then we'll have our 2 solutions. Negative 11 plus 7 over 2. Well, that gives us, what, 4, negative 4 over 2, or negative 2. And then our other solution would be a negative 11 minus 7 over 2, which gives us a negative 18 over 2, which is a negative 9. So x equals negative 2 comma negative 9. Okay, and we could probably check this too. Does that make sense? If it looks like we could have used factoring again, because those are 2 numbers that are really nice. If we multiply negative 2 and negative 9, that does give you 18. And, I think I messed something up. What did I do? Barf. Let's see. So another good skill is to go over and see if that makes sense. Sorry. Because here if we added those, that gives us a negative 11. And that wouldn't work. Oh, yeah. Sorry, that's just like the opposite. So whatever we came up with those 2 parentheses, and we would get something like x plus 2 and x plus 9. And then we came up with x plus 2 is equal to 0 and x plus 9 is equal to 0. That's where we end up getting our negative 2 and our negative 9. That's right. Okay, so just keep that in mind, I guess. So here, this would, if you factored, that's what you would get. But when you solve, you end up getting those opposite signs when you solve, okay? So that would work. So 2 times 9 gives you 18, and if we add, that gives us 18, or 11, sorry, my bad. Okay, so hopefully that makes sense. But either way, this way you could have done different ways to solve, but again, I'm asking you to quadratic. All right, so again, a lot of the time the struggle comes from knowing the order to simplify. Okay, so again, we want to do the discriminant, what's inside the root. We want to simplify the denominator, and then we'll simplify the root. These ones were perfect squares. That was nice. Sometimes you may need to do like 21. Maybe that would need to be or that wouldn't be a good example, maybe 20. So something like 2 and 10 and 2 and 5. Maybe you would need to do that and factor out a 2. Okay, so there could be something, these are just like examples. Okay, so 2 square roots of 5. Okay, things like that you could run into. And then the fraction, we'll talk about the fraction. This one's kind of important. Okay, let's see if we can find one that does that. All right, so here again, this is already in standard form. Make sure it's in standard form before you do anything else. Here we have a equals 4, so this is a little different. We wouldn't, perhaps this wouldn't work with some of the other methods. Okay, and then we'll substitute. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so now we will simplify our discriminant, so what's inside. So I'll just use my calculator. 10 squared minus 4 times 6 turns out to give you 4. So we get x is equal to negative 10 plus or minus the square root of 4 all over 8. Okay, and then we know what to do next is the root, so that gives us negative 10 plus or minus 2 over 8. Okay, and here we could simplify our fraction. So here is something that you should do, and make sure you realize this, is if we were to try and simplify this fraction before we try and, do the plus or minus stuff, we want to look at the 3 numbers and see what can we divide all 3 of those by. Okay, it's like, we'll write it here, it's like the 3 musketeers. And that's not how it's spelled, and I'm sorry. Okay, musketeers, no idea. Okay, so, but you got the idea. It's all or nothing. It's all for one and one for all. Okay, so here we can divide 10, 2, and 8 all by 2. So maybe we will do that. And we'll get x is equal to negative 5 plus or minus 1 over 4. For this one, it doesn't really matter because when you're all done, you would get one answer. Either way, you'll get the same answer. But when we start getting like roots and things like that, then it gets really important that you make sure you do the 3 musketeers. Okay, so negative 5 plus 1 over 4, well, that gives you negative 4 over 4 or a negative 1. Or negative 5 minus 1 over 4. That gives you negative 6 over 4 or negative 3 halves. So those would be our 2 solutions. X is equal to negative 1 or negative 3 halves. Okay, it looks like just looking at the types of problems, my guess is that we probably could have used factoring because we don't have any roots or imaginaries. But we would have had to use grouping. So, okay, so those are the 3 things to simplify. Some tips: always standard form first. Okay, so please always, if you have stuff on one side, you need to move everything to one side. I mean, if you have things on both sides. Okay, and then use parentheses when substituting. I think that's a really good idea. I didn't do it all the time. But I'll show you an example of where you could run into issues. So that's why I would ask you or suggest to do it all the time. And then use a calculator to simplify your discriminant. All right. Okay, so here's just some other examples. Watch as many as you can. Some of these may be important and some not. Okay, some may be simpler or similar, okay? So, like looking at this, let's label our things. A equals 1, B here, again, the sign goes with it, so a negative 4, and C is equal to 10. So X equals negative B. So here is a common mistake here. It's a negative B, and B is negative. So we'll have a negative 4. will give us a positive. So let me put a little star on this, okay? That's a common mistake. So x equals negative b plus or minus the square root of b squared. Here's another common mistake, is not putting it in a parenthesis. Oftentimes people will do negative 4 squared and they say their answer is negative 16, which if you plug that into your calculator, that's what it would give you. But the negative should be squared too. So this would be bad. This is what we want, parentheses. Okay? I got to start over with the song. X equals negative b plus or minus the square root of b squared minus 4, it's always 4, a, which here is 1, c is 10, all over 2a, which is a is 1. Okay, so we'll simplify what's inside the root. So again, that negative 4 squared, that gives you 16, minus 4 times 1 times 10. Okay, here this ends up giving us the square root of a negative 24. Okay, and what does that mean about our solution? What type of, is it going to be rational, irrational, or imaginary? Or a combination of those, okay? So think about that. We'll simplify our denominator, which is just 2. And we can also simplify this part. That gives us a positive 4. I guess we don't need the plus there. It would just be 4 plus or minus. Okay? All right. Now we're going to simplify the root. Again, you probably will want to see if we can do like a factor tree. So 2 and 12, 2 and 6, 2 and 3. One group of 2 will come out, and the 3 and the 2 will stay inside. So we'll have 4 plus or minus 2 square roots of 6. Okay, and also we have this negative inside, so we'll take that out and give us an I. So 2i square roots of 6 all over 2. We're almost done. So we did discriminant, denominator, root, and now fraction. Again, we want to do the Three Musketeers. So we need to see, what can divide 4, 2, and 2. We do not do anything with the roots, okay? We can't divide something by a root, by like a whole number, okay? So we'll only look at those numbers in the front. So it looks like we could divide everything by 2. So that would give us x is equal to 2 plus or minus 1i, or you could just do I square roots of 6 all over 1. And if you just divide it by 1, that doesn't change anything. So those would be your two solutions. Maybe I won't skip that step, but 2 divided by 1 is 2. This divided by 1 is the same, so that doesn't change anything, okay? And then we could write it as 2 plus I square roots of 6 and 2 minus I square roots of 6. Okay? So looking at that, there's no way we could use factoring to do this type of problem. There, you couldn't find two things that multiply or add. You probably could have done completing the square for that one. All right, so here's another example. A is 2, and I know some of you guys will just want to write it like this. I would suggest that you write them separately so you make sure you have the right, like the negative 6 on there. C is 5. Okay, so x equals negative b, a negative 6, plus or minus the square root of b, negative 6 squared, minus 4ac all over 2a. Right? And maybe give this a pause and see if you can finish this up by yourself. Okay, so we have x is equal to, we have a negative, negative gives us a positive 6, plus or minus the square root. We'll simplify our discriminant, what's inside. So negative 6 squared gives us a positive 36, minus 4 times 2 times 5. That gives us a negative 4, all over 4. Okay, so then we want to simplify our root. So that gives us 2i. Okay, again, if we have a negative, bring it out, give us an I. And then the square root of 4 is 2, all over 4. Okay. And then our last step is to simplify the fraction. So again, 3 musketeers. Looks like we could divide all of those by 2. So we would get 3 plus or minus I over 2. And we would just leave it just like that. Well, I guess unless you wanted to write it like this. So 3 plus I over 2 and 3 minus I over 2. All right. And then these last two, these are kind of important as well, just because this isn't in standard form. And that's one thing that students will forget, is they will just have it in right order. And they'll say, oh, that's A, and that's going to be B, and that's going to be C. But that would be totally wrong. It would mess up all your answers. Okay, so we need to first write it in standard form. So we would add 5x to both sides. And then we would subtract h to both sides. So minus 8 is equal to 0. Then you could say, well, A here is 5, B is 5, C is negative 10 or 8. And then we'll just plug all that in. Okay? You can skip past this part if you feel like you're good, or pause and give it a try even better. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, we'll simplify the discriminant. So that's 5 times 5 is 25, minus 4 times 5 times a negative 8. So again, put it into parentheses. That ends up giving us the square root of 185 over 10. Okay. And then you could do a factor tree to simplify our root. I don't think it's a perfect square, so we could maybe do 5. So we'll divide that by 5. That leaves us with 37. And then 37. I think that's prime. I think we'll be done. Let's see. Let's double check. Yep, so that would be done. We couldn't go any further than that. And since we don't have anything in front of our root, we can't simplify our fraction. Okay, again, it's all or nothing. If you wanted to, you could put a 1 in front of that, and we'd look at these 3 numbers and say, what can we divide all 3 of them by? And since we can't divide any of those except for 1, then we are done. Okay, so some of your ones are fairly straightforward or quick. Okay, so we could do negative 5 plus the square root of 185 over 10, and negative 5 minus the square root of 185 over 10. All right, last but not least, okay, if you're missing a term, replace it with a 0. Okay, so if you wanted to, please write it like this, plus 0x minus 8 is equal to 0. Now we can label A is 3, B is 0, and C is negative 8. Okay, and if you could choose a method, I would not use the quadratic for this one, because you could just use square roots to solve. You could add 8 to both sides, divide by 3, and then square root. But let's see what we end up getting. So x equals negative b, so that's 0, plus or minus the square root of 0 squared minus 4ac all over 2a. So we'll simplify the discriminant. So you could put the 0 if you wanted to. 0 squared is just 0, minus 4 times 3 times a negative 8 gives us a positive. So we'll have plus or minus the square root of 96 over 6. Okay, and I don't think that's a perfect square, so we'll do a factor tree. It looks like we could take out a 3, and that will give us 32 And then we could take out a 2 and 16, 2 and 8, 2 and 4, and 2 and 2. So there's one group, there's another group, and then we'll have a 3 and a 2 stay inside. So we'll do plus or minus 4, so that's the 2 times 2 gives us the 4 square roots of 6 over 6. And then we would want to simplify our fraction. Okay, so 3 musketeers doesn't really matter because we don't have a 0 there, so it's just those two. Looks like we could divide by 2, and we'll get plus or minus 2 square roots of 6 over 3. Okay, and then we could write it separately if we wanted to, so 2 square roots of 6 over 3 and a negative 2 square roots of 6 over 3. Okay. So let's just double check. Let's do this the other way. If we added 8 to both sides, we get 3x squared is equal to 8. And then if we divide both sides by 3, and then if we square root, so we'd have x is equal to the square root of 8 over 3. So that is the square root of 8 over the square root of 3. And we could factor out a 2, so that would give us 2 out in the front. Okay, and one of the things we haven't really talked about is that we should never have roots in our bottom, our denominator. So to get rid of that, we would multiply top and bottom by the square root of 3. And that would, the square roots would cancel. We'd get 2 square roots of 6 over 3. And that does give us the same thing. So it works either way. That one's kind of a little tricky since we haven't really covered that kind of stuff, but it's kind of cool. Anyways, so that is it. Again, these are kind of steps. Identify them, please, A, B, and C from standard form. That's important. Okay, substitute those values in. Simplify the discriminant and denominator. And then simplify the radical. If possible, you don't always can. Like this one, we couldn't simplify it. And then simplify the fraction if possible. 3 musketeers. Nice, right on time. Okay, so there is a derivation for coming up with the quadratic formula, but I'll probably save that for if you're really interested. I could make a separate video for that. All right, well, shoot me an email if you have any questions. I hope this helped, and we'll see you next time. Next time we're just going to compare those methods and see which one works best for certain situations.